All right, thank you so much for joining us today. And we are here with Math 202, Vector Algebra and Differential Equation. And what we are going to do is we are going to start with the vector algebra aspect first, right? So we are going to learn vector algebra, do some examples before we move to differential equations. Right, so let's just start. I'll start with the vector, and the first question that I'm asking, what is a vector? And we know that a vector is a quantity that has both magnitude and what direction. So something like, if I have something like this, and let's say this is the origin, and then this is what the ending point, then you should have a magnitude and what a direction. So if this one is AB, then we are saying that this is having a direction and also having a magnitude. So we will learn magnitude of vectors very soon. So that is basically one thing that I just wanted to tell you under vector, right? And example of vectors that has a direction and magnitude. We can talk about velocity, right? We can talk about force. We can talk about acceleration. They are all examples of what vectors. Now, let's start with, so as we are going, I'm showing you some of the terms and we are solving some examples. I will leave some of the questions for you to also solve. Then you put your final results in the comment section. I'll be grateful when you do that so that we can, have, kind of connection there. We can connect with checking your answers and seeing whether they are right. Right. So now what is a position vector? Now we are saying that basically a position vector is something that's coming from, let's say, the origin. So for example, if I have this line here and I have this. So this is actually coming from the origin, right? So a position vector is coming from the origin, and you should have something like this. So this is a position vector. Now we are going to name this one x-axis, and in the x-axis we have the I direction. So this is going to be the I direction. Anytime we are on the x-axis, we have the I direction. And then on the y-axis, we are going to have J direction. Right. So you will see that wherever we have x, anytime you write x, we add the direction to it. So like xi, yj, right? That is kind of something that we want to do. So that is basically what we want to do with the position vector. So one thing that you need to know is with this one, actually we are talking about the two dimension, right? So this is two dimension or two dimensional, right? So because we have just the plane, we have y and we have x, so we have the two dimension. We will talk about the three dimension, but before we do that, now we know a position vector is kind of like starting from the origin, of the axis of the point in the space. So basically that's what we are just doing, but let's take some example to see what we are just trying to say, right? So what we want to do here is, given this, find the position vector of A. So what will be the position vector of A? So it's very simple. We are saying that the position vector of A is equal to 3i plus 5j. So remember, this coordinate here is x and this coordinate here is y. So we said that with the x-axis, which is the coordinate for x, is going with I, and then the y-axis is going with j. So if I want to find the position of this one, I'm just going to add it. So xi plus yj. So this kind of, let me write the general form for the two dimension. This one will be like xi plus yj, right? And this is going to give us x is 3 and then y is 5. Good. So basically that is the position vector that we are going to get from there. So that is two dimension. Now let's look at the three dimensional, right, aspect. So the three dimension is going to be something like, if I have something like this. Good. So we did math 101 and then we looked at how to sketch, on the XYZ plane. So this is the x axis, this is the y axis, and this is the z-axis. So same idea from the two dimension, but this one is I, this one is J, and we've added another one. This one is going to be called K. So this is the three dimension, right? So this is three dimension. So this is a three-dimensional. So what you need to know is when we go to the three dimension, we have z to be equal to what? 0 from there. So we have the 2 and we have the three dimension. So let's look at what we are just doing here. So with the three dimensional, we are going to have, so we have example here. So the position vector for this, the position vector of A, oops, this one's supposed to be B, okay? Typing mistake. So this one should be B, should be equal to, this is going to be xi plus yj plus zk, right? So this is x, this is y, and this is z. So we are going to have this one to be 2i plus 7j. Let me write my j well. And then plus or minus k. So this is what we are going to get for when it is in three dimensional, right? And this is when it is two. So when we are in the two, it's like basically plus 0k because we don't have z, and then that aspect is 0, right? So basically that is position vector, right? It's very simple. So what we just need to know is, like, we are now learning the basis, and then we put all of them together to start learning what we want to do. Now let's see this one here. So what I want you to do is, I want you to find the position vector of A, position vector of B, which is here, and then so this is the two dimension and this is the three dimension. I want you to find position vector of A and position vector of B, but I want you to also try finding position vector of A. I didn't talk about it, but what I want to do is, okay, basically let me do the B for you, but this is what you need to do is first find A plus B before you find the position vector. So A plus B is going to be like 0, 2, minus 3, plus minus 2, minus 3, and 1, right? So what you need to know is, we with vector we add component by component. So this will add this will add this, and this is going to add this. So this is x, y, z, x, y, z. So we are going to have it to be, so 0 plus minus 2 is going to give us minus 2. 2 plus minus 3 is going to give us minus 1. And then minus 3 plus 1 is going to give us minus 2. So when you are done, so this is how, when you simplify, you are going to get. So when you finish, write the position vector 2 for this one too as well. So in this playlist, what we are doing is, if I do A, you to do B. So if I solve example, I give you try example to also try as well, right? So when you are watching it, you can just pause it and then you can work it through. When you are done, you can just type it in the comment section for me, and then when you finish, you continue, right? So now that we know position vector, right? Now that we know position vector, what you need to do is we need to look at modulus or length or the magnitude of a vector, right? So as I was trying to say, we learned from Math 101, how to find the modulus of 2 points. So we are saying that, let's assume that A is having a component ax, ay, meaning that this is the x component, this is y component. Then the modulus or the magnitude of OA is equal to just ax squared, right, plus ay squared, as we just written it here. And the same thing, if it is three coordinate, that's where we are in the space. We have x, y, z. X, y is we are in the plane, and that's why we are in the space. So x squared, y squared, z squared. But one thing that I want to let you know is, let's assume that we have, this one is not starting from the 0. Like, I mean, This is not a position vector because this is a position vector. That's the reason why you're having something like this. So let me show you something here. Let's assume that we have something like A, which is equal to 2, 1, and 3. And let's assume that we have B, which is equal to, let's say, 0, -1, and 4, right? And we want to find the magnitude of AB. Now we need to use the same idea that we learned from level 100, math 101. But here, the idea is that the point is 3. So I'm going to have, if this one is my x1, y1, z1, this will be x2, y2, z2. So the equation will be x2 minus x1 squared plus y2 minus y1 squared plus, so since we are in a space, we are adding another term, which is z2 minus z1 squared. So that's what we are going to do. So when you pick the point, the first one will be 0 minus 2 squared minus 1 minus 1 squared, 4 minus 3 squared. Then you simplify. So that is when you have 2 points so that you don't confuse yourself. And then one important thing is this. It's very, very important. Very, very important. We are going to use it. If you have a squared is the same as the magnitude of this one. Remember that we said when we were dealing with math 101, or if you have forgotten, one thing that you need to know is, let's take example. Let's assume that a is just a value, right? So let's assume that a is 2, right? If a is -2, then what is -2 squared? This is 4. Then what is -2 absolute squared? You see that because this is absolute, the absolute will even take care of the minus and make it positive before we square it and come and get 4. So we are saying that if we have absolute squared, then we can just take out the absolute and just put the square there, because it is squared, it can take care of the absolute sign, or it can take care of the negative values, right? So this is very, very important, right? So now that we know how to compute the length or the magnitude of a vector, right, we want to look at some examples, right? Let's pick some examples. So first thing that we want to do is, now we want to find the magnitude or the modulus of A and modulus of B. So this is mine. When I finish, I'll give you practical example for you to do. So modulus of A is going to be, we know that this is, since this is x and y coordinate, I'll just write x squared plus y squared, and this is going to be 2 squared plus 3 squared. This is the same as 4 plus 9, and this is going to be root of 1, 3. So that's what I'm going to get at the end of the day, right? With my point. So I have my A, which is 2, 3, and this is A, which is x, y. So my x is 3, my y is, my x is 2, and my y is 3. So this is the first one. What will be the second one? Second one, I have B, which is 1, 2, 4. Now this is my x, this is my y, and this is my z. So the magnitude will be equal to x squared plus y squared plus z squared. That's what I'm going to get for the magnitude. Then this is the same as, what is x? 1 squared. What is y? 2 squared. What is z? 4 squared. So what are we going to get? Root of 1 plus 4 plus 16, and this is going to give us root 21. So this is what we are going to get with the magnitude. So let's look at something here. We're able to do the 2-dimension, and we've done the 3-dimension. Let's pick question on this one too, right? So that when I finish, I can give you some question to also try your hand on that. So oops, oh, I don't have question on that. Okay, let me write question on this and then we just go. Okay, we can just talk about it later. We will just talk about this one later. So since we don't have question on that here, maybe I'll bring it in the next 2 slides. So what I'm going to do is, I'm just giving this to you for a trial, right? You can just drop the answers in the um, comment section when you are dropping the answers. The first one that I give to you, you can say this one is the first example. So like trial 1, and then this one will be trial 2, and then you just put your answers in it. So we want you to just find the magnitude, the modulus of A, B, and then adding A and B, C, D, and adding C and D, and then just finding the modulus. Good. Now let's talk about unit vector. It's very important in this course. Unit vector is very important. And one property that you need to learn under unit vector is the magnitude of a unit vector is equal to 1, right? So it's very, very important. So let me write that point down. It is a vector with magnitude equal to 1. This property is very, very important, right? So anytime we are saying that this vector is unit, then it means that when I find the magnitude, I should be able to get 1. I should be able to get 1. So let's assume that we are going to denote this one like, let me just denote it like this. Maybe your anybody who is teaching the course can use different symbol, but all you need to do is you understand it, right? So this is the unit vector. So that's what you are getting. Now, what's the formula for finding the unit vector? So the unit vector, which is a cap, is equal to the vector A divided by the magnitude of vector A, right? So here what we are doing is we are assuming that A is a vector. So for us to make sure that this vector A is a unit vector, then we need to divide it by the magnitude of that vector. So that is some of the important thing that you need to know here. So what are some of examples of, let's say, a unit vector? Let's note this one down. So for example, in 2D, so when I say 2D, 2 dimension, we have a I. What is I? Remember we said I is in the x direction. So I is 1 and 0. It's very important. We are going to use this one often. Very, very important. And B, J is in the y direction. So we are going to have 0 and 1. It's very important. So let's check. These are some examples of unit what vector. So let's look at this. When I find the magnitude of this, magnitude of I, what am I going to get? This is just 1 squared plus 0 squared, and this is 1 plus 0, and this is root of 1, and this is 1. So it means that I is a unit vector because it's having a magnitude of 1, right? So anytime you want to check if something is a unit, just all you just need to do is just find the magnitude and check it out, right? And see if it is a unit vector. Same thing to this one. The magnitude of J is equal to 0 squared plus 1 squared, which is equal to 0 plus 1, and this is going to give us this, and we have 1. So that one too is what? A unit vector. Let's look at 3D, right? 3 dimension. So with 3 dimension, we have I. Remember, with 3 dimension, we have x, y, z. So we are going to have 1, 0, 0. And what will be the magnitude? The magnitude of this is going to be 1 squared plus 0 plus 0. And this will be 1 plus 0 plus 0. And this one will be 1, which is equal to 1. Right. Let's look at the J1. So now you know the pattern, right? So the J is going to be 0, 1, 0. And the magnitude of this, it basically is going to also be 1. Then let's look at the last one, K, because we are in the space. So 0, 0, 1. And we can see that when I find the magnitude of this one too, I'm going to have 1. So let me just write something short. So 0 squared plus 1 squared plus 0. This is going to be root of 1, and this is going to be 1. This is going to be 0 squared plus 0 squared plus 1 squared. This is root of 1, and this is going to give us 1. So these are some of, some of the things that you need to know, and they are very important when we are doing this. When we are talking about dot product, when we are talking about cross product, and all those things, which we'll get there very soon, you will see that we are going to use this a lot, right? So this is a unit vector. If you have any question, you can just drop it inside the comment section and I'll attend to that. So what we can conclude here is I, J, and K are what? Unit vectors. Let's take some example and then we will see what we can do. So given this and this, find the unit vector of A and unit vector of B, right? We want to find the unit vector of A and unit vector of B. So what did we learn? We know that first question that we need to ask ourselves is what's the formula for finding a unit vector, right? So we said the unit vector. So the first one we said the unit vector of, let's say, A, right? A unit vector, the unit vector of A is equal to A divided by the magnitude of vector A. So this is what we are going to get at the end of the day. So what is vector A? Vector A is actually the position vector, right? So we need to make sure that we write it in the position vector form. You remember position vector, right? We just learned it. So we need to make sure we write it in the position form. So A, which is 3 and 4, will be equal to 3i plus 4j. That is the position vector. Then what we need to do is now we need to find the magnitude. Magnitude is equal to root of, so the magnitude, we just pick the coefficient of this and then we put it here, coefficient of this, and we put it here. Later on, we will look at when we square this and when we square it, what are we going to get? So this is going to be 3 squared plus 4 squared. What is 3 squared? 9. What is 4 squared? 16. When we add, we get root of 25, and this is going to give us 5. So now we can conclude that the unit vector of A is equal to, now we have this one, so the position vector divided by the magnitude. So we are going to have 3i plus 4j divided by 5. And bet you can try to find the magnitude of this and you are going to get 1. This is the unit vector, because remember this is going to be 3 divided by 5i plus 4 magnitude 4j divided by 5. And when I find magnitude of this, I'm going to get what? 1. Because when I square this and when I square this, I'm going to get the same thing, and then I'm going to get it to be 1. So that is one thing that you need to have in mind. The magnitude of a unit vector is just 1. Let's do the last one here. Now we are looking at B. So B is 1, 2, 4. So this is going to be I plus 2j plus 4k, right? So we just need to add the directions to it. Then we need to find the magnitude of B. So root of 1 squared plus 2 squared plus 4 squared. So what are we going to get? 1 squared is 1, 2 squared is 4, and then 4 squared is 16. So this is going to give us root of 21. So now what will be the magnitude of B? Basically, the magnitude of B is going to be this divided by that, and then we are done. So let me just clean this so that I can conclude with the first question that we were just doing. Good. So the unit vector of B is equal to the position vector, which is I plus 2j plus 4k, then I divided by root of 21. This is the unit vector. And when I find the magnitude of this, I need to get 1. So that's one way of verifying if your answer is right. And let's look at this example here. If x is a unit vector, so as soon as we are saying that x is a unit vector, then mind you, it means that it's going to have a magnitude of 1. Find the magnitude of y such that this is equal to this. So what are we looking for? We are actually looking for the magnitude of y. That's what we are looking for. But remember, we did some theorem here, and then we learned that, where is it? I think it's here. We learned some theorem that a squared is equal to the magnitude of a squared. So it means that we can apply that thing here. So since we know that, since a squared is the same as the magnitude of a squared, this implies that we can write this one as magnitude of y squared minus magnitude of x squared, and this should be equal to 8, right? Because if a squared can be written as this, then y squared can be written as this, x squared can be written as that. Now, what is the property of x? We are saying that x is a unit vector, and we are saying that a unit vector has a magnitude of 1. This implies that we are saying that since x is a unit vector, then the magnitude of x should be 1. So that is one thing that we need to learn from there. Then we are going to have the magnitude of y squared minus 1 squared is equal to 8. So magnitude of y squared minus 1 is equal to 8. Then magnitude of y is equal to 8 plus 1. So if I want to continue from here, I'm going to have magnitude of y squared to be equal to 9. And taking the square root, I'm going to have magnitude of this to be equal to 3. So that's what I'm going to get at the end of the day. So this is very nice. So we see that now we can conclude that the magnitude of the vector y is 3. The magnitude of vector y is 3. Good. So basically that is what we just need to get here. So one thing about math is, what you are learning is what you just keeping, because basically when you learn and you'll be able to remember that, okay, I learned this, then it actually helps you to understand what you are doing again, right? So basically that is everything that we are doing here, right? And these things that we are learning, you will see that you need to go and apply in other course. So it means that if you are forgotten this one, then it means that you cannot apply them in the next course that you are going to take. Is that right? Yeah. So that is basically what we are just doing here. So let me give you a try example, then you try, right? So I have x, I have y. I want you to find the unit vector of x and y. So find unit vector of this and that. And I've given you a similar example. If a is a unit vector, find b such that this is equal to that similar one, right? So that you can practice the example that we just did here. All right. So I think this is the end of the video, and then yeah, I think so. So this is what I get for you and this. So in the next video, what we are going to do is we are going to also learn different topics, and then when we are done, what I'm going to do is now I mess up the questions and then we solve them together. I hope you enjoyed it. See you in the next video.